Today we're going to look at moles and stoichiometry. There's two different definitions for stoichiometry, but the main thing you're looking for is you're studying quantities of relationships either within chemical formulas or within chemical reactions. So you have the two types listed here. Composition stoichiometry deals with looking at relationships among elements and compounds. So when you're writing formulas, we're doing empirical formulas, we'll be doing percent composition, those kinds of things. And then for reaction stoichiometry, you're going to have to be able to write a balanced equation, use that information to determine quantities of substances as they undergo chemical changes. If you remember from a while back, AMU means atomic mass unit. This is the unit we use to express the mass of an element. So if you go back and look at your periodic table, you can look up these values on the table. These are the ones that have the decimal values, and we usually just round to the nearest whole number. So for example, if you look up carbon, it should be approximately 12. If you look up zinc, it's going to be around 65. The mole is related to this. The mole is the SI base unit for quantity of matter. It's based on the number of atoms that are found in 12 grams of carbon-12. It's also based on another number that's referred to as Avogadro's number. And this value you should memorize is 6.02 times 10 to the 23. This represents the quantity of atoms, molecules, that's the two we typically use, ions, isotopes, or formula units in 1 mole of a substance. So we're going to be using that as a conversion factor in just a little bit. One of the main ones you want to look at is the mole related to grams. The AMU for an element is directly related to that mole. If you take the atomic mass unit and express it in grams, that's basically the number of grams that would be in 1 mole. So for example, if you took up sodium, which has an atomic mass of 23, that would tell us that 1 mole of sodium would equal 23 grams of sodium. This will be another conversion factor that you'll be needing to use. This is just a slide that goes over some different definitions. Molecular mass is a term used to describe the mass of typically molecular compounds. Formula masses are used to determine any type. So I usually just use gram formula mass and use this little abbreviation GFM. Molar mass is the mass of 1 mole of a compound. As far as quantities, there is no difference in the values that you would use here. So if you had the molecular mass of water, it would be 18 grams. Its formula mass would also be 18 grams. Its molar mass would also be 18 grams. The only difference is in the definition. So the first thing we're going to look at is determining the number of atoms in a formula. So if we look at the chemical formula for water, which is H2O, remember the subscripts are the little numbers that are below the elements, and they're going to be after the element that they represent. These represent the number of atoms of each of those elements you would have in that particular compound. So for water, you can see that we would have 2 hydrogens and 1 oxygen. So you have to be able to get your number of atoms first before we can get our gram formula masses that we'll be solving for in a moment. So let's look just at a couple of these. If we look, for example, at number 2, you can see that you have 2 hydrogens in your H2SO4. You have 1 sulfur, and you have 4 oxygens. And if you add all that together, that's going to be 7 atoms of elements in this particular compound. But this is more important that you understand how many of each of the atoms you have, because that's what you're going to use when you're getting your gram formula mass. Now if you look at one like number 8 where you have a parentheses, then remember you're going to use it like the distributive property. Since this is outside the parentheses, it just means that you would have 3 of the calcium. But since this is in parentheses, you would take the 1 times the 2, or you would have 2 phosphorus. 4 times the 2 would give us 8 oxygen. So let's look real quickly at number 15, similar kind of situation. You have 1 nitrogen in parentheses with a 3 outside, so that tells me that I would have 3 nitrogens. Here I have 4 inside the parentheses, 3 outside, so that would tell me I would have 12 hydrogens. These are all outside parentheses, so you just use whatever the subscript is with them. So this would be 1 phosphorus and 4 oxygens. So try some of the others and see if you have any problems. Once you figure out how many atoms you have, we can use this information to determine our gram formula mass or our molar mass. So if we go back and look at water, remember there's 2 atoms of hydrogen, there's 1 atom of oxygen, and then all we have to do is multiply each of those quantities by their atomic mass. So remember, hydrogen's mass approximately is 1, so if I multiply that together, that'd be 2. Oxygen's mass is around 16, I only have 1 of those. If I add these together, that's going to give me 18, and what that's telling me is that in 1 mole of water, I have 18 grams of water. This can be used as a conversion factor to go between the mass of something and moles, or vice versa. So let's try this one. If you have magnesium, in this formula, how many atoms of magnesium do you have? Well, there's not any, it's not in parentheses, and there's not a subscript, so that just means that I have 1 magnesium. If I look up its atomic mass, it's going to be 24. Manganese, it's in parentheses, the 2 is on the outside, there's a 1 on the inside, so that would be 2 manganese, and it's around 65. And then oxygen, I have a total of 8. 4 on the inside, 2 on the outside, so I'd multiply that together, and then I would have 16. Then I would simply multiply all these out and add them together to get my gram formula mass. So let's look at number 2. We've already broken this down into atoms already, but we'll do it again real quick. So we have 2 hydrogens, each at 1, so that's going to give me a total of 2. I have 1 sulfur at 32. Remember, I'm getting these off of the atomic masses on the periodic table. I have 4 oxygens, each at 16, for a total of 64. If I add all that together, that's going to give me 98. So what that's telling me is that in 1 mole of H2SO4, I'm going to have 98 grams of H2SO4.